Kids, hello. Hi. Hi. Hi, kids. All right, today we're going to do a very short video on perpendicular vector components. You, so far, should already understand how to add vectors. You know, if I have this vector and then I want to add this vector to it, you should understand, well, you add vectors by putting them tip to tail, and then you would get your resultant vector. And then hopefully you would understand, you would name it using that angle, and you could get the whole deal and everything. All right, so that is adding vectors. That's taking two separate vectors and adding it to get to one. Well, perpendicular vector components is essentially just the opposite. It's kind of working backwards. So it's, I have this vector, and I want to break it into two perpendicular components that add up to that. Well, how would I do that? Well, I could say this would be my horizontal component, and then this would be my vertical component, where, hey, look, that's a right angle. Or you could also draw it this way, too. It would be the same difference. You could go vertical component, horizontal component. But those would be my two perpendicular components. And you might ask, well, why the heck would you ever want to do that? Well, here's the answer why, and we're going to be doing this in this first unit, is let's say you throw something at, I don't know, let's say you throw a ball at 20 meters per second. That, by the way, is about 40 miles an hour because it's roughly double. And let's say you throw it at 20 degrees above the horizontal. Okay, so you're kind of throwing it up at an angle. And the question is asking you to be like, hey, find the two horizontal component vector and the vertical component of it. Well, so what do? Well, first you draw your picture, because in physics you always draw your picture. So let's draw your picture. So here would be my horizontal component, and then there would be my vertical component, where again those are perpendicular to each other. A lot of times we're going to call this the x component, because just like in math class, x for horizontal, and this the y component, because just like in your math class, y is for vertical. And then I need to find these two sides. Well, this is where you just have to use your mad trig powers. So Katoa, yep. So you guys can do it however you want. I've had some students use law of cosines. I don't really care. I just want you to be able to solve it. I personally like, you know, sine and cosine. So if it was me finding x, I would set it up like this: cosine of 20 equals x over 20. Okay, maybe I'll make this 25, just so we don't get confused with the same number. Okay, so it'd be cosine of 25 equals x over 20. Okay, and then you could solve for x. And if you do that, make sure your calculator's in degrees. But if I do that and I take cosine of 25 times 20, I get 18.13. Now here's where you got to be careful. You got to include units. If you don't say units, you sound like a crazy person. So you would have to say meters per second, but you would also have to say the direction. So in this case, I could say either east, or I could just draw an arrow saying that way, because again, your components are vectors. And then if I wanted to find this side, I could do Pythagorean theorem and say this squared plus y squared equals 20 squared. Or I could use sine. So I could say sine of 25 equals y over 20, and then plug my numbers in and solve. Or, like I said, if you wanted to, you could pretty much do whatever you wanted. So this would be 8.45 meters per second. So y equals this. And then maybe this is north, maybe it's up, maybe I'll just draw an arrow going that way. But that's all you have to do to find your vector components. Super duper easy. Bye, kids.